G'day everyone, my name's Andrew. As you can tell by my accent, I'm from Seattle. No, I'm actually from Sydney, but I do live in Seattle, working in the Microsoft mothership. And I work on a team that is all about game development outreach. And today we're going to talk about why Microsoft is doing what they're doing in terms of bringing everything together under one place. For me, game development has been a personal passion for about 30-something years. My first game I created was on a Commodore VIC-20, if anyone knows what that actually is, in 1982. And I've been creating games and helping other people make games ever since. I've been at Microsoft for about 10 years, and in that 10 years, I've traveled the world helping game developers make games from Australia to the US to Europe to South America. So it's been a lot of fun. I love pursuing that passion and helping other people do more. And so today I get the privilege of talking to you about what we've done at Microsoft to repivot the entire company to help you guys do more. So why are we here? Why is Microsoft here with Unity? Well, when we think about game development, gaming itself, it's a different beast today than what it was back then, when I created my first game. Or even 10 years ago, or even just a couple of years ago. It's very, very different. And right now, we expect to have things like digital distribution. That didn't exist. We expect to have achievements and gamification in our games. Those things didn't exist. And then, community. Everything now is all around a community. Without those things, without the ability to game on the go or pick up where I left off, a game is a non-starter. And so when we think about those types of things, we're really thinking about a different way of doing game development as well. It's no surprise that our tools and technologies have had to evolve. And so we're looking at this new sort of modern game development world where things are constantly changing and your needs as a developer are constantly changing too. And so Microsoft has had to think about how we approach game development and how we approach supporting you as game developers to make sure that you have the best chance of success. 30 years ago, you'd ship your game and you'd be done. Fingers crossed you didn't have like a game-killing bug in that thing because you were dead in the water. 15 years ago, even on the console, we started being able to ship updates. But those updates were really restricted to more like patches and really tiny edits to the game. And Mech Assault was one of the very first original Xbox games that actually took updates. Today, though, we're in this constant cycle of creating and operating a game. We expect to have that feedback on itself where anything we learn from a game being shipped is fed back into the process that we can make that game even better. Rather than moving on to the next big thing, what we are seeing is we're incrementally making this big thing the next big thing. And so we need to find ways that allow you to monetize and measure and engage with your audience and grow them. Today we're actually looking at players who need to be reacquired on a monthly basis or a weekly or even daily basis. You can't just count on someone being captured in one instant and be a lifelong fan. You need to figure out ways to be able to engage with them regularly and bring them back into your game over and over and over again. And because of that, the only successful game is a game that's not just built well or run well, but it's also nurtured well, all equally important, all equally needing that care and attention that you as a game developer need to give them. And so when you think about that full spectrum, the creating and operating and the build, run, nurture sort of mentality, you need to have the tools and services that speak to each other, regardless of what stage of development you're on. Now, Microsoft has been through decades of evolution ourselves, even in the gaming space, from our early DOS games like Flight Simulator to Windows gaming to Xbox and ultimately to new devices that are pushing the boundaries of when and where you can play. Xbox One, HoloLens, xCloud and more. And we're continuing to evolve our own approach to gaming. And so we're choosing to double down on game development as a concept so that we can actually help you guys as well. You can see on the screen there are many, many products that sort of fall under the GameStack banner. And all of these products can help you, and they're all actually aimed to help you achieve more, but we haven't done a fantastic job on making sure we're focused on the right thing. And so when we did that, we wanted to reorient the entire company's approach to how we help you as game developers. We couldn't do that when we were saying, hey, buy Visual Studio or buy Azure. It was more a case of we tried to figure out how we could shoehorn you into us. And we had to just turn everything completely on its head for game development. And this is something that's very specific we've done for the game development industry, so that we're actually focused on you first and starting with the problems you face, the scenarios that you encounter every day, and figuring out things that we can do to help you achieve more and fix those things and figure out how to actually solve those things. So how could we do that if we were still product focused? So we changed it, and we went back to the drawing board from the ground up, and we looked at what you guys go through when you build a game. You know, in the modern game development lifecycle, there's two distinct loops that are equally important. There's the classic loop, the create loop, where you design your game, you build the code for it, you then test it to make sure it's going to run, and then you publish it out to your customers, your players, right? But critically, as critically important is the operate loop, where you monetize that game once it's out there. You measure its success. You get the insights to know whether it's being played the way that you expect or whether you need to change things. You engage with your players, find ways to constantly bring them back, and then you find ways to grow your customer base. Obviously, I've written this as an infinity symbol because both loops, they're not independent. They feed back on each other. Obviously, without creating things, you don't have anything to operate. But once you start measuring and getting insights, you know where you can actually make adjustments. When a game is a live game and it's operated well, all of these 8 stages are as important as each other. And so once we actually sort of established the fact that we wanted to be on the journey that you guys go on, the 8 stages, what we then could do is start looking at key scenarios that you face, common scenarios that anyone faces in this sort of modern game development world. And so when we did that, we can then say, only then, we could say, what products do we have that might be able to help you out? So going back to this screen for a second, I could talk probably for about 4 hours, but I'm not going to bore you all of that on each of these products. So what I'm going to do is, when I talk about these scenarios, I'm just going to focus on 2 products today, Azure PlayFab and Microsoft Azure, that can help in this area, both operate and create loops, and all the different scenarios. And the reason why I'm doing that, the reason why I'm just focused on 2 is because, not just because I could talk for hours on all those products, but even just one of these products could do so many things. And before I look at the scenarios, when I look at Azure, there's all sorts of things that Azure can do. There's whether it gives you the compute power that you need that your local on-premise devices can't do, with virtual machines and all sorts of containers to be able to hold that compute. Or different types of storage, SQL or NoSQL databases, or Redis cache, things like that. The ability to build the apps that you want to build, whether they be web or mobile, content delivery networks, all that kind of stuff. And then doing all sorts of machine learning and AI in the cloud to take that cognitive service load off your local machines and putting it up there in the Azure cloud to be able to get that insight that you're going to need into your game's operation. You've got the ability to develop and deploy, build the way you want with cloud batching and doing sort of DevOps and App Center in the cloud to be able to test your games on mobile devices and things like that. And then finally, all the kind of networking that you want, hybrid or local or on-premise stuff. So that's just one sort of product that I was using as a baseline for when I looked at the scenarios you faced. and I asked myself, what could we do to help you with those areas? Remember, that's the key is here that when I looked at these are scenarios that were created and generated from discussions with dozens and if not hundreds of game developers, both inside Microsoft in our first-party studios and outside, well, it's as recently as GDC back in March in San Francisco, where we sat down with quite a few different game developers and asked them what kind of scenarios that they are faced with on a daily basis when they think about a live ops enabled game. Each of these is just one of many, but I'll dive into these now. So global game servers is, why does that matter? Well, if you want to get the biggest player base, if you want to have access to the most number of customers for your game, you're going to need to be able to get it across the world, right? But it can't just be delivered and distributed as broadly as possible. It also needs to perform well. And so for that, you need to have servers that are located around the world to reduce latency and to meet all sorts of sovereignty rules. There's a number of countries where they really require the PII, the personal information of a player, to be restricted and constrained within their region. And so you need to be able to work with some sort of a provider that allows you to do that, to give your game that flexibility and that scope. And some of the problems that you face when you do that, from other game developers is, hey, we need to be able to optimize costs by scaling up and down, right? So you want to be able to say, hey, I suddenly have this big influx of gamers and I need to have more servers online. You need to be able to do that quickly. You can't afford to have queues that are some days old where certain games took a really long time to spin up a new server. You can't afford to do that in today's world, in the modern game developer world. But you also need to scale back too. You don't want to pay for servers you're not using. So you need to be able to spin those up and down. And hand in hand with actually being able to spin the servers themselves up and down, you need to be able to put that functionality into those servers quickly. And so you need to containerize that. You need to put that into some sort of easily deployable form. And then low latency and high speeds, high clock speeds are certainly things that we hear from game developers. There are a lot of options when you look at the cloud, and if you don't have the right servers that are performing well, you're not going to get the performance that will be able to do sort of a lot of the cloud machining that you need for your game. And then finally, security is also another big thing. DDoS attacks are like a common daily thing, and so you need to be able to have that kind of protection. And so once we actually established that was a scenario that you face, once we actually looked at the challenges or heard the challenges that you guys face when you're actually building and implementing that, it was only then that we could look at what could Microsoft do to help. And so we looked at two products, Azure, to build your own. So you could do things like create your own virtual machines with a system in place to auto scale. You can use Kubernetes to containerize that deployment very easily, and you can use Azure DDoS protection, which uses the CDN to actually make sure that you're mitigating DDoS attacks. Or you could actually implement a managed solution with Azure PlayFab's multiplayer services that we have. The reason why Azure is potentially a great fit for you is that we have a large distributed network of regions and servers. And in some instances, there are places that only Azure can provide you that access. So the UAE, for example, we're working with other cloud providers to be able to use our cloud network to be able to implement their games in that area, because Azure is the only one that has data servers there. Remember that data sovereignty. Some countries really restrict how you get your game there. The second scenario I want to highlight, and these are the two big ones, the globally available game servers and live ops and analytics. Without your game being a live and operated well game, it just doesn't fit into the modern game era. And so to do that, you need to get those insights. You need to be able to analyze your game and do really good measurement of what's happening there. And if you do that, then you can actually capture some great growth options and opportunities. To be able to get great live ops, you need to be able to do things like analyze your player data, segment your players, see what they're doing, be able to predict how they're going to progress through your game so you can actually then start building out your next bit of functionality or your new features. You want to be able to know all of that stuff because you also want to be able to mitigate cost, right? And so, for example, ad spend, you want to be able to optimize when and where you put money into your ad spend. To do that, you need that insight. You need to know where players are at. There's no point in advertising a new feature if they're all still stuck on level 1. And then finally, game location analytics was another thing we heard a lot, that people want to know where people are playing their games so they can figure out how to optimize maybe their global game servers. Again, we have 2 different options there, build or buy. Basically, when I got back to that point of, yes, what can Microsoft do to help? First one is using Azure with Databricks and Data Explorer. Use the machine learning capabilities and be able to rely on things like cognitive services and stuff to be able to analyze from an artificial intelligence perspective those insights, give you a lot more depth of insight there. And then the other one is to use PlayFab's analytics and insights engines. We even have an analytics plugin for Unity that allows you to visualize when and where events are occurring. So you can actually determine where overload is happening on frame rate, for example, because a lot of players are camping in particular spots, or there's a lot of high activity in those areas. And you can see it over time and things like that, that you can just see right in the Unity engine what we're actually doing with relying on the Azure stuff. The third area is game data and storage. So now we've got our game servers. We know how to distribute our games. We know how to get to the players. And now we know information about the players, but we need to also be able to store all that data. And you need to be able to make it reliable and available to you regardless of where you are. And so you need it to be globally available, you need it to be scalable, and you need to be able to get access to it fast. And so with Azure, you've got a whole bunch of options to fit your particular development model. You know, again, we're going back to what do you do and what problems do you face. And so you can build your own with Azure SQL. You can use Cosmos DB, which is a NoSQL option, or Redis cache. We actually had a recent mobile RPG launched that used Azure SQL, and they have at launch about 500,000 queries a second, which translated to about a gigabyte of data per second of a transaction log in that first hour of launch. Like that was a little bit eye-opening, right? They now handle about 12 billion player events per day, which also translates to hundreds of billions of data rows per month into that database. Once you have all that stuff, it sounds a little bit backwards that I'm now hitting development and deployment, but you need to understand some of that design consideration before you even start development. So this is another area where, as a developer, you're now becoming more and more reliant on being able to offload a lot of the work that you're doing. And so things like cloud builds and cloud rendering are incredibly important for you. Using Azure's batch rendering and the CDN, you can totally offload a lot of that build process. But in addition to that, you can use DevOps and App Center to be able to build and test your game. And you can use other tools like Simplygon to do 3D rendering, and Project Acoustics, which actually allows you to do a 3D modeling of your sound in your game as well, to be able to determine how sound is bouncing around the room. PlayFab also has some development integration where you can use a new entity programming model. It integrates with App Center and Azure Functions and uses Visual Studio Code integration as well. We have online game services to make sure that, when I say we, I mean game developers, need to have those online game services to engage with players. You know, once your players are playing your game, you need to be able to give that ability to engage with them and have them do more. And things like leaderboards and tournaments are like basically a day-to-day occurrence now for game developers. And so you can build your own with Azure Virtual Machines and event hubs and notification hubs, or you can rely on Azure's PlayFab's multiplayer which is now in public preview, to be able to dynamically scale custom game servers around the world with queue-based matchmaking and leaderboards. The final scenario I want to sort of highlight is cognitive services. With the ability the requirement to be able to be globally available, that comes with a challenge of having people speaking different languages, writing in different languages, and wanting to be able to talk to each other. And so, the challenge of being able to do real-time text and speech translation, both back from text to speech and back, or converting languages, is a critical one in modern game development. And then when you get that, when you're able to actually translate everything into something that you can consume, then you can do all sorts of cognitive service, machine learning-based analysis of that content. You can do sentiment analysis, you can do video content analysis, you can even do customer support automation, because you can actually build these bots and cognitive services through Azure, or you can use PlayFab, something like PlayFab Party. I just want to quickly play a video of how one developer is currently using MySafe GameStack.
Sea of Thieves is a new type of multiplayer game. We call it a shared world game.
It's a cross-play title. You can play on PC or on Xbox.
How do we create something that can scale to millions of players and then keep those players engaged over weeks and months and years?
PlayFab multiplayer servers provides a pool of servers. As the number of players throughout a given day increases, we can pull those servers online in a very short period of time. We try to ensure that players have the lowest latency to the servers as possible. So we deploy into 6 data centers around the world.
We don't want to leave you playing on a server on your own. So this is where our server migration technology really comes in, where you can look at the population of other servers and either move your crew from your server or move another crew from their server onto a server together.
The game client and the game server are written in Unreal Engine, and they are both connected to Azure via WebSockets. So we have a live connection between the game and our services. Azure provides a cluster of servers that we host our services on. The services that provide our server matchmaking functionality, our migration functionality, or our commerce functionality.
Having these separate services, this does allow us to update each service independently without affecting the player experience.
We use everything from Azure data factories to richly and speedily combine data, through to the navigation of data through Power BI and Azure Data Explorer. We're beginning to see a new generation of games that you couldn't execute without the cloud. We've got the ability to update the game and keep on adding new content.
This game would not be possible without Azure.
So I'm told that my talk time is getting cut short a little because of the keynote going over. Who knew? So I'm going to sort of scroll through a couple of these things. The other customer I wanted to highlight was Wizards of the Coast with their latest Magic the Gathering game, Arena, that was based on Cosmos DB and Azure, where they handle millions of transactions every day through a bunch of different information cards. Uno uses PlayFab to give all their statistics and insight across globally. And so all of these things to say that when we think about GameStack and we think about Microsoft, what we want to do is figure out how you guys are building your games in this modern game development world, and that what scenarios you face and what we can do to help those. So hopefully that high-level view was really helpful for you. I'm going to leave you one last video, and thank you for your time.
The hardware consists of a master control and 2 player control units.
Good shot, yes! Thank you, Andrew, for your presentation.